Today's topic is optimization of the requirements engineering process and the techniques using the systems engineering suite. My name is Cecilia Karlsson, and with me I have my colleague Christer Fröling, CEO at the Reuse Company Scandinavia. This is the agenda for the webinar. First, we will have a description of the company and the presenter. Then Christer will talk about knowledge-driven systems engineering. Next is work product quality. We will take a look at systems engineering tools, interoperability, traceability of work products, and verification and validation. Finally, we will have some time for questions and answers. Let's start with a few words about the Reuse Company. The Reuse Company was created in 1999 as a spin-off from University in Madrid by systems and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm and a delegation in Tokyo. In 2021, we are planning to open an office in the US. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic knowledge-centric approach. The Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. You can also apply these concepts to other topics. So let me introduce you to the presenter. Christer is the CEO of the Reuse Company Scandinavia. He has over 2 decades of experience in successful implementation of systems engineering and its sub-disciplines. He has been working with both development of advanced technical systems and with public organizations in specification and procurement of complex infrastructure projects. Christer is one of our principal consultants and is specializing in applying systems engineering and design thinking into organizations willing to adopt change and implement a knowledge-driven and lean systems engineering approach, focusing on information quality, knowledge build-up, and reuse with a passion of coaching others. He is also an appreciated lecturer, teacher, and a strong believer in knowledge sharing and networking. So let's start with today's topic. Hello, Christer.
Hello, Cecilia. Thank you for that lovely presentation. So let's begin by talking about our concept of knowledge-driven systems engineering. When you think about systems engineering, we almost always also think about managing complexity. Complexity is growing for every day, for every system, for every thing we are trying to do, we introduce more and more complexity, I would say. And system engineering is a very good approach, I would say. But we as human beings, we still lack the confidence in managing all of the things that we are looking into. And many times when we try to introduce how to describe complexity, we end up getting even more complex, I would say. And this is easy to understand because in this world we are driven by different types of systems, and they are more interconnected than ever. And systems engineering has often thought that the solution for this is to introduce model-based systems engineering as the solution for managing complexity. And I would say that that's one of the things that we need to do. We need to go from a document-driven approach to a more approach which looks into the complexity and the different aspects of things. But if we take a look at the process ISO 15288, we can easily think of one thing that we actually don't spend so much time upon, and that's knowledge management. Knowledge management is a forgotten gem in our jewel, I would say, because if we can manage the knowledge, because everything we do introduces knowledge into the organization or into the product or into the project, we are much better off. And we can also say that in today's world, we don't lack data, and perhaps we don't even lack information. But at the end of the day, when it comes to knowledge, it means that we need to understand the data, form it into information, appreciate it as knowledge, and use it for a shared understanding. And from organizations like in COSE, this is actually one of the visions, because we need to understand that model-based systems engineering, for instance, will help us, but it will not be the one and only solution. And in a typical project or in a typical organization, you can easily understand and appreciate that within the different disciplines and within the different workflows, we introduce a lot of data, a lot of information, and also a lot of knowledge. But it's very much captured within the tool you're working with. So this is just an example how it could look like, where you have a multiple of tools throughout the development practice and throughout the development process. And what we want to achieve by introducing a knowledge-centric approach is actually perhaps not to drag in the information like I show in this picture, but more to tap into, because the master of the information is always in the source, but we want to tap into it, we want to interpret it, and we want to reuse it as an asset when we do other things or checking things, for instance. So by doing so, we can create a shared environment, a shared knowledge base, or ontology as we call it, where we actually can understand that everything should fit together, like for this example, the car. The requirements, the architecture, the design, the test, the verification, everything should point us in the same direction, even if it captures different pieces of that information puzzle. So in a typical process like this, which actually is a very good one, the ISO 29110, which is a simplification of ISO 15288, we can actually see that we have different portions of information, different parts where the information takes different routes. So if we start off simple and think of team communication, we have typically a bunch of people that works with requirements. Okay, that's quite typical. And these people, they typically have their work practice, they do it in their way. Also, typically, they use natural language, for instance, English or other languages, but in this example, we can talk about English. They usually put those requirements in a requirements management tool, like this one, or there are others, of course. And what happens then? Yeah, we need to understand that we need to as we can see in this process, we need to review the requirements so that we can validate and verify with the stakeholders that we actually have captured the right thing. But what about the system architecture and the system architects? Because I'm deliberately saying that these are not the same organization or not the same team. It's typically other people doing the architecture. And it isn't hard to understand that these two views and viewpoints should point in the same direction. But are they writing requirements? No. They're probably using another type of tool, like the Capella tool, for instance, or other tools, to capture different architectural views, like functional, physical, state machine, so on and so forth. And by doing so, they are introducing more understanding and more ways of managing complexity, like I said, with introducing model-based systems engineering. But they are not writing English. They're using other languages like SysML, UML, and so on and so forth. So it's not very easy to actually do the review of these things, because we should compare the requirements not only with the stakeholder needs, we should compare it with the architecture or the proposition or proposal of the architecture that we have in hand. Is the information correct? Is the requirements showing the same thing as the architecture is stipulating, and vice versa, of course. It's very easy to understand that we're introducing bugs here, because the reviews typically end up looking into the requirements is isolated, perhaps also within the tool. Like modern requirements management tools, they actually propose that you do the reviews within the tool itself. So it's very easy to be isolated in the reviews. And the same goes for reviewing the architecture. You probably do that also in the tool. So what happens then? Is it easier or harder to capture the notion that you are not correct, that you are lacking things? And what happens if you proceed? Yeah, the information pours down to the people that needs it, typically the development teams. It can be one team, it can be multiple teams, it can be multiple continents, multiple organizations. So the problem are multiplied if we have any problems, of course. Because how can we say, or how can we verify when these organizations or people come back to us and talk about, I think we are incomplete, or aren't we inconsistent, because the architecture says something and the requirements say something else. We are also typically starting to running late. Okay, money is spent on late changes to fix things when we realize that we actually are incomplete or we are inconsistent. First of all, we need to decide, is it the requirements or the architecture which is wrong? And we end up having management attention and a lot of angry people trying to understand why we can't cope with these things. Okay, but I would say that it's typical lock-in of the information which isn't shared and it isn't treated as knowledge. If we treat it as knowledge instead, and make it possible for us to tap into that, for instance, with our knowledge manager, we can actually start to talk about knowledge-centric systems engineering, where we can retrieve and reuse, which is one of the key things when it comes to the application of knowledge management. We need to make sure that we are interoperable, and for that reason we have adopted the OSLC schema, where we can quite easily, I would say, create connections to other types of information sources, like different types of tools. And when we can do that, it's possible for us to do reasoning. Are we incorrect? Are we incomplete? Are we inconsistent? And we can also verify and validate the quality of the information as such. And of course, one important thing when we talk about reuse is that we can use information from one source to create information in another, like authoring requirements using the models, the PBSs, for instance, in a model-based tool. And by doing so, it's possible for us to share, and we can learn from each other. So this is the way we should start to think. A knowledge-based systems engineering has some key things which we have to bear in mind. First of all, we need to have a shared vocabulary. So we need to, for instance, decide what are the languages we are using within the organization. If we are a multi-site organization, it's typically quite common that some organizations, they use English, some other use Japanese, and the third one use German. And for that reason, it introduces more complexity, of course, because then we need to understand how the languages fit together. So we need to look into the language. And after that, we have the other step, which is actually to look into how the information is shared. What is the architecture of the information per se? If we have product breakdown structures, if we have synonyms to words, if we have cluster of words and terms, and so on and so forth. And when we have that in place, it's possible to start to create semantic structures called patterns, where it's possible for us to use those patterns both for checking inconsistency and completeness, and also for enable us to create new information. Because the key here is to understand that the requirements, for instance, that we write, they should be treated as an asset, and also a way for us to stay within the scope. And when we have these patterns in place, we can start to formalize, we can start to look for inconsistencies, and we can start to reason about the content we are looking at. So it looks fairly simple, right? It takes a little bit of time, but it's absolutely doable for all organizations out there. And here are an example of different languages that we support, and more is there to come. And they are freely downloaded on our web. So you just download the language, you connect it, the language database ontology to your knowledge manager, and you actually start to work from there. And as I said, this is not the only truth for us. We need, besides the language, also look into the domain. If we, for instance, work within the car industry, we must enable the car language, so to say. What are the typical terms when it comes to the car domain? And then, of course, we have the possibility to provide libraries. And libraries is a very beautiful thing. And here is a screenshot from our webpage, where we support different libraries, mainly at this point, different libraries for patterns or different libraries for quality functions, for checking requirements. And they are also freely downloadable, so you can just access those. And it's possible for us to actually have more information and more knowledge in place. And of course, we want to use other sources, like for instance connecting to model-based tools, because that's shared information for us, or should be. And this is not a typical presentation from us. We are not sharing any demonstrations or anything, but on our webpage, or on YouTube, I should say, it's possible to look at different videos. And this is a video, here's the link, for how we are actually capturing information within the Knowledge Manager. And when it comes to work product quality, I've started to talk about that a bit. You know that we are often talking about correctness, completeness, and consistency. And what that means is that one work item can be correct. An individual requirement or a model element or any information element, I could say, must be able to be correct. Okay. But then we also have the issue of completeness and consistency, as I described, and that's for a set of requirements or a set of information. And we then need to understand that we need to be able to verify and validate the information to other sources. We need to compare the requirements with the models, for instance, so that we actually can say that we are probably complete or probably consistent when it comes to the information. Because at the end of the day, we can just provide that information to the people or organizations deciding. We can just suggest that we think that you are incomplete or that you are inconsistent. And as I said, there is multiple issues with requirements these days, I would say. We are not treating them as they are supposed to be treated. And this is a study made in 2015, where we actually can see that the odds of actually failing the project has different reasons, but it's fairly interesting to disseminate these figures. Of course, there should be odds of failing when you are not meeting the test cases. Okay, of course, but look at the changing and unclear requirements. It's a huge portion of projects failing when you see that you have a schema of changing and unclear requirements, and that's not so hard to understand, right? And I often talk about what I call the death spiral for a project. If this is a typical setup where you write requirements out of your stakeholders and stakeholders' needs, if you're not doing that proper, you will interpret those stakeholders and those stakeholder needs into a set of incomplete, inconsistent, and incorrect set of requirements. And it's actually quite interesting to think on why is that happening? Why aren't we better on developing a good set of requirements? But in any case, if we do that, it's not very hard to understand that that requirement will be developed into a crappy system. I call it a crappy system. And of course, that crappy system will have a hard time passing the test and the verification. And if we pass it through the verification, sometimes I actually see that people are changing their requirements because they don't match the design rather than the other way around because you don't have time. You end up with unhappy stakeholders because they are not receiving the system they actually want. And to look more into that, just to conclude this, I usually talk about the problem space where you are looking into the problem as such. And if you're not doing it correctly, as I said, you will probably define the wrong system and you will end up not understanding the complete problem, okay? And when you then start to look into the solution domain, regardless if you write requirements or if you produce a model, for instance, there's a risk that you actually are making the wrong decisions. One very typical thing is actually that you start to create what we typically call is capturing the design too early. So the solution will not be optimal. And when you come to that specific solution, of course, it has the possibility to be wrong because you can't verify it against the requirements again. And I just bring up this picture because this is quite typical when you work with procurement, where you actually as the buying agent are supposed to write your requirement, and then somebody else is there to actually create the design. And if you have a huge lack here, you will create a problem when it comes to procurement. So this is a very simplistic picture. You have your stakeholders. From that, you develop requirements. And from the requirements, you get a design and eventually a system. And you understand the notion of verification and validation. So I won't go much further into that, but it's actually the system that needs to be verified against your system requirements, and the validation is against your stakeholder needs. So why am I choosing to show this picture? Yeah, that's because the requirements as such are still a key thing for us here. And what we want to introduce is the possibility to check those requirements much earlier than when you're actually checking them against the system when you're doing the verification. So what about being able to check for incompleteness, incorrectness, and inconsistency when it comes to those requirements? You will be very much early in the design, and it will be very much possible for you to understand and go back to your stakeholders and verify that you actually are correct or incorrect with your requirements and fix those very early. And also, we should be able, as I said, to be able to compare the design or the architecture, I should say, with those system requirements to see that we have kind of a backward and forward compatibility. And here again, when we are purchasing something, it's actually somebody else that provides the design and we are providing the requirements. So for purchasing organizations, it's even more crucial that you get those requirements correct. And I've been talking very much about requirements, and requirements are often written in text. And as such, we need to understand that that text is something we need to be able to check, okay? But I said again that requirements are not the only thing that you should look upon. You should look upon more things, and that's very often the solution, which are created first of all in models. So again, what we are interested in is actually to compare requirements written in natural language with the solution side, which is very often models not written in kind of a proper language. So we need to have metrics, and Incosa has created metrics, for instance, for checking requirements, but we need to create also metrics to actually be able to check and verify and validate that the information going from needs to requirements to architecture is actually in the right place. And the key here, as I said before, is using patterns. What we say is that we want to use patterns for writing requirements, but we also want to use patterns for checking and comparing requirements against models, for instance. And when we have those patterns in place, we can start to check for inconsistency. We can check for inconsistency in naming, where the model is talking about some entities and the requirements are talking about something else. We can talk about overlapping both requirements and also requirements compared to models. And also we can talk about more complex things like how we allocate properties and so on and so forth. Okay. And if you're interested in more information, we could look into, for instance, this video where we look into quality with our RQA tool. So please look into this video if you want to have more information. And I've been talking about knowledge management and how you should tap into different sources of information. And for that reason, we need to understand that we need to have interoperability, because the ecosystem out there is complex. These are just two examples of complex architecture when it comes to different tooling. So you can see here that it's not just one tool, it's many tools within the design, within development, testing, operation. And you have tools for requirements, you have tools for testing, for modeling, for analyzing, for many things. And for that reason, our tools have been created with that in mind, so that we could tap into the information where it's actually stored, where it's the source, and because we don't want to overlap information or recreate information. We want to be able to reuse that information, both for creating new information, but also for checking things, okay? And in this ecosystem we are creating, our system engineering suite, it actually tackles the requirements quality by offering different tools and processes. And I should say that we fairly automatic can actually measure the requirements quality. For instance, using the Incosa metrics and creating own metrics for completeness and consistency compared to other sources like models. So we can connect to the requirement side, and we can connect to the architecting side and the simulation and the side where we are creating the design or the solution, I should say. And for that reason, we have created the rich authoring tool, the RAT, which actually assists us to create new information out of tapping into different sources of information using those patterns. And the RAT authoring tool can be connected to many sources from from actually the Microsoft suite of Office Pack tools to very potent tools for modeling and requirements management. And this is a webinar we recently had where we described how we can connect the RAT to the Capella modeling tool for creating correct and complete and consistent set of requirements using the RAT as the authoring. So please check this video out if you're more interested in that. And as I said, RAT is not only connected to, for instance, Capella, we are able to connect to multiple tools. I would say most of the tools on the market. You can also check for other videos we have on the web page, or on YouTube, I should say. So when it comes to traceability, that's the key, because if you don't have traceability, you can't keep track on where you are in your system, and you can't keep track on where you are in your project, and you will have a hard time managing change. So typically, sources like in COSE or 15288 or other system engineering processes describe the need for traceability. Basically, in this picture, all the arrows show the need for traceability. And since these practices also are recursive, it means that we create a multitude of need for traceability, because one source will be divided or traced to multiple other sources that will be traced to even more sources. So you will end up having a very huge traceability matrix. And when talking about traceability, most of you probably know what traceability is all about. But when you look into, for instance, the INCOSA handbook, it says that tracing is about establishing and maintaining. Don't forget that it's not just a one-off thing here. Maintaining traceability between not only requirements, but also other relevant elements like stakeholder requirements, architecture, interface definitions, analysis, test, verification methods, so on and so forth. So it's multiple sources of information that needs to be traced. And for a project, it's crucial to know what traceability is all about, because you need to know the situation in the project, because you will not lack data, as we saw before. You have multiple sources of data, but which is correct? Where are you in the project? What's the situation? Have you tested your requirements? Are they verified? What's the status? And are you complete? Because you can use the traceability to check that you actually are allocating information to the next stages, and that you are capturing the things that you want. So both for checking for incompleteness, but also for over-completeness, where you actually are creating new assets of information in the design, which is of no use because you can't trace it to any valid requirement. So you will introduce a great visibility for yourself, which of course introduces a much better way of collaborating within the teams, within different roles, like requirements managers, architects, designers, testers, and even the suppliers and customers, because you have a shared interface. You know that something needs to be communicated over a trace. And of course, you can create traceability matrix very simple, I would say, by just setting up a Microsoft Excel sheet. And as a first step, it's much better than not doing anything. You can, for instance, trace test cases to use cases to see that you actually can show where the requirements are coming from. You can check that you have test coverage for all your requirements, and you can ensure that the implementation actually have the capacity of fulfilling the need. You will not see it before you have done the actual verification, but you can see that you are on the right track. So for some projects, I would say it's quite enough. but those are not in majority, because most of the projects are complex. So you need to have a better traceability schema in place, I would say. And it's not good for decomposition, because if you see this picture, if we decompose this and actually break this down, you will have a depth in this picture which is not possible to manage just by having markups in an Excel sheet. And of course, you will not satisfy standards like, for instance, the safety standards for cars, the ISO 26262, for instance. Those are not satisfied by a simple Excel schema. And safety is of concern. And when you look into the standard like 26262, for instance, you need to ensure that each source of safety requirement is actually traced to upper hierarchy level, but also that you can derive it to the next lower level in the hierarchy, so that you can follow the traces almost down to the code element, but at least to the functional elements. And also not forget about the verification. So we are here actually talking about both horizontal and vertical traceability. So this is introducing the complexity in traceability. And again, when we talk about traceability, we need to realize that the traceability is not within one tool. It's between different tools. If we are going to follow this standard and we have this working environment, we need to understand that if we have the requirements in IBM, and we have the testing in HPQC, and we have other tools involved in this, we need to create traces between different domains, between different tools, which actually have different types of artifacts and different types of internal languages. And for that reason, we need to understand that this is a simplified example of the same thing, where we actually have the contractual requirements in simple Microsoft tools. We have the technical set of tools with both requirements and models, and we have the testing side for system and for software testing, and then we have the product management side. And many organizations, they create different types of export-import schemas, where you take information from the requirements, put it in the test environment, or you create simple mechanism that pushes information from one side to the other. But it's not very easy to use, and it's very time consuming and needs manual attention, I would say. So why don't look at more proper tools like the Traceability Studio? Here we actually are using the knowledge manager in the background and using the OSLC connectivity to create these links between the different environments, so we can actually manage the traceability in a way that we should. And the pros are many. You must consider traceability for complex and safety critical projects. And you need to do that according to the good practices described in, for instance, ISO 26262. And the negative side, of course, it's first time you try to do this, it's tedious and it's very manual, and you need to do it the first time. And it involves connection to many tools. But our tool, the Traceability Studio, actually uses the knowledge base and the patterns and everything we have built up to actually also propose traces that we can semi-automate the investigation of items that should be linked. So we can propose links for you. And if you're more interested in traceability, please look into this video, which is recorded and published on YouTube about smart traceability. And now we comes to the last part. That's the verification and validation. Most of you know, as I said before, that verification is basically to look that we have built the system right, okay, and we are fulfilling those system requirements. And the validation is actually just to make sure that all the stakeholders are happy, they are getting the right system, we are solving the right problem. So the verification needs to be set up that we can reduce risk and we can obtain a useful system. So in order to reduce risk, we need to have a verification schema set in place, which is not a big bang. You should start to verify as soon as possible, down to subsystem level, where you can start to look into the verification of those, to find risks early and to reduce the problems you see. Because it's all about risk reduction. The verification and validation are just one of many tools that you as a project manager have in your tool set to make sure that you are doing the right things. And if we do reviews of requirements, we do reviews of architecture, we do different analysis, tasks, simulations, design inspections, component tests, and so on and so forth. You have a lot of information here, which you actually can start to tap into to start to verify your system in a very timely manner. And for that reason, we also look into the notion of 15288, saying that all work products should actually be verified. It's not only the system and the system components. And as I've been saying throughout this presentation, if we find errors early in the process by setting up the verification, so we actually find errors early, it's much easier to fix them, and they absolutely don't cost that much money to fix either, comparing to if you actually find errors or severe bugs in your system when it's in production or even deployed in operational environment. So for that reason, we have created the Verification Validation Studio, which actually, in the same way as the Traceability Studio, enables you to tap into the information you have in hand, so that you can start to prepare for the verification, to select items to be verified. You can define how you want to define the verification actions for each verification item, which is not only requirements, I should say. And you can help in preparing resources and identify what are the needs and so on and so forth. And then you can perform the verification. You can set up a computerized system that actually suggests this, that the verification action is a pass or no pass. And of course, you can set up, or this provides the engineers with the interface to have a complete overview over their verification. And then at the end, you can start to manage the verification results, to track the process or the progress, I should say, and also create reports, so that you are able to show where you are in your development effort. And if you're more interested in verification and validation and the Verification and Validation Studio, again, we have a YouTube video on how we are implementing ISO 15288 and the VMV processes using our tool. So really what I've been describing is how knowledge-centric approach, where you actually are seeing all the different items of information, items of data as sources for knowledge, and by using a knowledge-centric approach where you actually are storing information and reusing information using a knowledge base, you will manage complexity in a much better way, and you can ensure quality, and you can also make sure that the knowledge is shared and reused, not only in one team or one project, but also throughout the organization that uses these techniques. So I've been describing the Knowledge Manager, the Traceability Studio, the authoring tool for authoring new types of information like requirements, the quality studio for checking different work items, for instance, requirements or models, and also the verification and validation studio for making sure that all work products are verified and validated at the end of the day. And our goal is actually to look into all the different work processes within 15288. So we will have some great things to show after the summer for you as well. So that was actually the last slide from my side. So thank you very much.
Thank you, Christer, for your presentation. Christer will answer your questions in a minute. So if you want to ask him anything, please write down your questions in the chat box and address them to everyone. While you're writing down your questions, I will give you some information about our next webinar. It's called Tailoring and Deployment of the Systems Engineering Suite in Fusion for Energy. Fusion for Energy is the European organization managing Europe's contribution to ITER, the world's largest fusion experiment. Fusion for Energy has authored more than 700 technical specifications with more than 80,000 requirements in total. The Systems Engineering Group has adopted our Systems Engineering Suite to improve requirements quality and support the requirements management and verification process. This presentation will focus on the steps that were taken to tailor the Systems Engineering Suite to Fusion for Energy's needs, lessons learned, and the results from the pilot projects which have started using the Systems Engineering Suite. The date for this webinar is the 29th of June, with one session in the morning and one in the afternoon. So let's see if we have any questions. Thanks for an interesting presentation. You mentioned tools interoperability. If I have a tool that I want to connect to, can you do that? And is it difficult?
Okay, thank you. Interesting question. I would, on the top of my head, say yes, because we haven't met any tools. Well, of course, the tool needs to allow us to tap into the tool itself so we can actually get the data. But we have actually developed a good practice for developing these connectors. So I would say in a month or two, we are able to connect to mainly every tool that's out there. So please get in contact with us if you need more information on that.
Okay. I want to improve my total requirements engineering skills and wonder if I should get a requirements management tool before I start to use RQA, and which one do you recommend?
Oh, that's also a good question. It's a little bit like the hen and egg. Do I want to create good requirements first and then be able to store them? Or do I want to store the requirements and then check them? Regardless of how we answer that question, I would say that there are multiple requirements management tools out there. So I should absolutely look into what are my needs before I look into the tools. But I can just tease you a little bit, saying that we will look into requirements management using the Microsoft Office suite in the next set of tools that comes. So if you're interested in requirements management, let's have a talk how we can help you on that one.
Okay. We have no further questions, so thank you very much, everybody, for attending. As Christer mentioned, you can find recordings from other webinars and videos on our YouTube channel called The Reuse Company. And of course, if you have any additional questions or want to receive more information, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.